Now, we can use the things we know about special right triangles to help us come up with the trig ratios in terms of the unit circle. So if we start with the 30-degree angle, just to kind of prove the point, and drop a line perpendicular, now we have a right triangle. And this is our 30-degree angle, which would then make this our 60-degree angle, and this would be our hypotenuse. And what we know about, since the 30-degree is that and the unit circle is that we have a radius of 1. That would make this side length 1. Across from our 60-degree angle, our side length would be 1 square root of 3, and then our hypotenuse would then be worth 2, because 1 times 2 gives us a value of 2. Okay, so for our sine then, our sine of 30 would be opposite over hypotenuse. So the sine is equal to 1/2. And then our cosine would be, excuse me, adjacent over hypotenuse. So our cosine is square root of 3 over 2. And then our tangent is our adjacent over, opposite over adjacent, which gives us 1 square root of 3. And so then when we times by square root of 3 over square root of 3, we get a square root of 3 over 3. And if you do that for each of the different sections, you're going to notice a pattern that will run up and down the numbers. But luckily, people have already done all this, so we have this nice little trig chart so that you can, based on what your radians or degrees, you can always tell what your trig ratios are going to be. And your foldable, if you fold it into thirds, become a nice little reference guide you can put in your notebook.